When
It
are
is in chat.
okay? I see now. When are the finals? Let's see. I believe. Hold on. It should be the 10th or the 12th of May.
Thank you.
Okay, got you. Okay, next example. We're gonna try to do one, two, maybe three. Yeah, we're gonna try three more examples, Michael. So this is a cube root of x minus 1 equals -4. Cube root. Everybody see it?
Yes.
So, Kathy, is this radical isolated?
I don't see anything. There we go. Um, no. Yes. Yes, it is. Because
Yes, it
negative
is.
4 is on the right hand side.
Yes. So this is isolated. So the next step is to raise each side to a power equaling the root index. The root index in this problem is 3. Okay, there's your root index. So each side is cubed. And therefore, the cube root, and the third power exponent cancels out, leaving you with x minus 1. Comes out of the radical. And then -4 to the third power is not -12. It is -64. It's -4 times -4, which is 16. 16 times -4, -64. Then we will add 1 to cancel this. So x is -63. And actually, when we have an odd exponent, when it's odd, no need to check. Because when you cube root and odd, this will work out pretty straightforward. You won't get extra answers with an odd index. So when it's odd, you can pretty much leave that as is and move on to the next example. Questions on this?
Mm-mm.
Okay. We'll see how two more work for us. Let's try this. 8 plus 9 square root x minus 3 equal 35.
Is the 9 the index, or you just put the 9 like 8 plus 9?
9 is not the index. It is an integer in front
Okay.
of the radical.
Okay.
Thank you.
Okay. So this radical is not isolated because of this 8 and because of this 9. So we have to deal with these. One thing that we're not going to do is we're not going to write 17 anywhere because they're not like terms. So you can't add them together. So in order to isolate this radical, we want radical x minus 3 by itself. We're first going to subtract 8 to cancel the 8s. Then we have 9 square root x minus 3. This is 27. Then we divide both sides by 9. X minus 3 equals 3. Now the radical is isolated, so we raise each side to a power equaling the root index. The root index is a 2. Since we don't see anything here, that means this root index is 2. So it means we square both sides. So the 2 that is invisible cancels out with this 2 as the power. X minus 3 comes out of the radical. 3 squared is 9. To solve for the x, we add the 3 to cancel those 3's. And the answer is 12. So this is an even index. The even indexes we need to check. When we do that, we check in the original problem. And we will see if this is true. So here's the original problem. So since we got 12, we're going to put 12 right here where this variable is and see if this 12 minus 3 in the radical equals 35. So we get 8 plus 9 times, this is square root of 9. Does that equal 35? So this is 8. This is 9 times 3. Does that equal 35? So that's 8 plus 27. Yes, this equals 35. So that checks, and that's wonderful. And that checks out quite nicely. Okay. Questions with that? Questions with that? Okay, that's fine. That's good. I'd like to do at least one more. This one is, they won't get any longer than this next one. Okay, just want to show it to you. You might get one like this. So you just need to know how to do it. Just follow the process. Follow the process. Doing fine, doing fine. So 5 plus 4x plus 1 in the square root equals x. So this would be our longest one of the day. So if you can do this one, you can do everything, no problem at all. Everybody ready? Everybody ready? I want to make sure that we are ready to go.
Yes.
Yeah.
Thank you, Michael and Erica.
Yeah.
All right. So this radical is not isolated because of this 5. That means you have to subtract the 5. Subtract the 5. Those 5s cancel out. So what we have is the square root 4x plus 1. Now on the right side, these are not like terms. So we don't get negative 5x. We don't get x over 5. We have to keep these isolated, or I should say separated. X, you minus the 5, you get x minus 5. And over here, these canceled out, like I said. So now this radical is isolated. So we're going to raise each side, left side and the right side. We're going to raise each side to the power equaling the root index. This root index, if you don't see it, is 2. So we're going to square this side and we'll square the right side. So what happens? This 2 index will cross out this 2 exponent, and this 4x plus 1 comes out of the radical. Now, on the right side, we have a binomial that is squared. That means this binomial, you have to write it out twice. X minus 5 times x minus 5. So that means you have to multiply this out using the FOIL method. So you multiply those first, the x squared. You multiply the x times minus 5, minus 5x. You multiply the minus 5 times x, another minus 5x. Multiply the negative 5 times negative 5, positive 25. Let's bring the 4x plus 1 down. Here are like terms. Minus 5x, minus 5x, they're both minus, so that's negative 10x plus 25. Now, what do you do here? This x is squared. This x is squared. So what you want to do is you're going to have to set the equation equal to 0. And because you have this squared, then you're going to have to factor. Because you will have 2 answers. Why will you have 2 answers? Because when the x is squared, whatever this exponent is, it tells you how many answers you're going to have. So for this course, the highest x you're going to see is squared. 2 answers. When you go to college algebra, this might be x to the 3rd. So you have 3 answers. Or if that's a 4, 4 answers, and so on. How do you set this equal to 0? Well, what you're going to do is, I got to mute everybody. Did I just do it? I think I did it. To set this equal to 0, subtract 4x from both sides. And then at the same time, since that's plus 1, subtract 1 from both sides. So this, the 4x minus 4x, that'll cross out. The 1 minus 1, that'll cross out. So this side is 0. The right side, you bring down x squared. These are both negative, so we're going to add, keep the sign, negative 14x. We're going to have to subtract those, sign the highest number, positive 24. So this we have to factor. How do we factor? We factor using two parentheses. X's go in the first slot. I need two numbers that will multiply to 24 and subtract to negative 14.
2 and 12.
2 and 12. Very good.
2 and 12.
Minus 2. Minus 12. Because when you multiply those, you get positive 24. When you add those, you get negative 14. And who is Wi-Fi on the Zoom room? Who is Wi-Fi?
Wow. Murray?
Murray. Okay.
Sorry.
So how do we get two answers here? Now that factored, you get x minus 2 equals 0. X minus 12 equals 0. We're going to get two answers. Add 2 to both sides. X equals 2. There's one answer.
X equals 12.
X equals 12.
Add 12. X equals 12 is the other answer. So we need to, this is the even, it's the square root. So we have to check both answers. Because they could both be right, or one may not work, or neither one may work. So the way we check is, go back to the original problem. That's 5 plus 4x plus 1 equals x. That's the original problem. So we're going to replace the x's with a 2 and see if they equal each other. 5 plus 4 times 2 plus 1. Does that equal 2?
No.
This is 8 plus 1. So that is 5 plus square root of 9. Does that equal 2? It does not, because 5 plus 3 does not equal 2. This means the 2 will not check. Does not check. And since we have another answer, we have to do the same thing with the second answer. So I'm going to rewrite the original equation. There it is. Now we'll replace the x's with 12. So square root 4 times 12 plus 1. Does that equal 12? Well, this is 48 plus 1. That's 5 plus square root 49. Does that equal 12? This is 5 plus this is 7. And that does equal 12. So this checks. So this is your one and only correct answer. The 12 checked, the 2 did not check. So what do you think? That is
Hold on, I still want I was copying the bottom of it.
sure. So that's the longest that you have. Nothing would be longer than that particular problem. And hey, we know what? We have time for one more. And we'll do one more and call it a day because you've done very well. It's been a long week. We understand that. So this is where it started. And this took a page. That's okay. Not a problem. That is all right. Okay, ready for the last one, class?
Yeah.
All right, Erica, we're doing fine. This is it. This is it. The last example is 6x minus 5 in the radical minus x equals 0. So what do? We isolate the radical. We're going to add our x. We'll cancel that. Square root 6x minus 5. So 0 plus x is just x. Then, since this radical was isolated and it's a square root, we square both sides. So with this 2 as the index cancels the exponent. So 6x minus 5 comes out of the radical. X squared is x squared. So again, when we see this x squared, we're expecting 2 answers. So we're going to set this equal to 0. And then factor. The way we're going to set this to 0 is we're going to make this side 0. So if this 6x is positive, subtract 6x from both sides. If this is negative 5, then we add 5. Then we add 5 to both sides. So this will cancel, this will cancel. Left side is 0. None of these are like terms, so we keep them separated. X squared minus 6x plus 5. Now is where we factor. 2 parentheses. Put an X there and here. So what are we looking for? 2 numbers multiplied to 5 adds to negative 6. Those numbers
X
are
minus 1.
6 minus what?
5 and 1.
6 and 1.
Well, it's going to be 5 and 1. That's correct. Because it has to multiply to 5. And these will add to -6. So this gives us 2 answers. Set that first factor to 0 and the second factor to 0 gives us 2 answers. 1 and 5. 1 and 5. So for square roots, we should check the answer in the original problem. See if any of them work or one of them works. So first thing is we'll check the 1. Let's put the 1s in here. 6 times 1 minus 5 minus 1. Is that 0? 6 minus 5. So this is the square root of 1. Square root of 1 is 1. 1 minus 1 does equal 0. So the 1 checks. So we have 2 answers. So we need 2 checks to make sure that both actually fit, both actually work. So this time we're going to put in 5. 6 times the 5 minus the 5 that was already there. We're going to use 5 in the place of this x. Does that equal 0? So this is 30 minus 5. Again, is that 0? This is square root 25 minus 5. Is that 0? Well, square root 25 is 5 minus 5. That does equal 0. So that checks. So the 5 is good. So if you're going to put in your
So you got
answer,
2 answers?
you're going to have 2 answers. 1, comma, 5. So that will be your final answer once they both pass the check.
Professor, I have a question.
Yes, please.
So we have to always check it after getting the first stage.
When you have an even index, yes. Even for even indexes,
So
yes.
we have to always check it, and then we have to always check it, and then when we want to input the answers, if it doesn't, after checking it and you don't get the same thing you got at the top of it, that means you're gonna put just one answer, like the other one you did the 2 and 12.
Yes. So when we did the 2 and the 12, the 2 did not work and the 12 did. So that was our only answer.
Okay, so when we want to impute it, it's gonna be just the 12.
Yes. For this problem, yes.
Okay.
And for this one, they both worked. Good question, Olu.